All right, guys, we're going to continue with our area of regular polygon section. All right, looking at number 15, we have an equilateral triangle with a radius of 12. Remember, the radius starts at the center of your triangle and goes to the vertex, so I'm going to call that 12. And if I draw in my apothem, which goes from the center to the middle of the side, it forms this right triangle that I can work with. Things we can use with right triangles: Pythagorean theorem, special rights, and trig. You can't decide any of that, though, until you find this central angle right there, the angle at the center. And the central angle formula is 360 divided by twice the number of sides of your main shape. Since our main shape here is a triangle, we have 3 sides. So twice that amount would be taking 360 and dividing evenly by 6, which comes out to a 60-degree angle. Excuse me. Since 60 degrees is the central angle, it goes at that top angle of the triangle. Let me zoom in a little bit so y'all can see it better. With that 60-degree angle, that tells me that this is a 30, 60, 90 triangle. And I'm going to label my special numbers across from the corresponding angles. So across from the 30, according to your formula chart, across from the 30 gets labeled as 1. My 30 is here, so across from that would be 1. Across from the 60 is radical 3, so my 60-degree side would be this one. And then across from the 90, which is a, excuse me, your hypotenuse, gets labeled as 2. You always want to write the number underneath the number that's given so that you can remember to divide in and multiply out. So 12 divided by 2 gives me a 6 in the center, and when I multiply that out, 6 times 1 gives me an A of 6, and 6 times radical 3 would be 6 radical 3. Keep in mind, when it asks for side length, excuse me, that 6 radical 3 is just part of the right triangle. If this is 6 radical 3 and the apothem splits that side in half, that means double that amount would be the side length. So the side length comes from twice the length of our triangle side, which would be 12 radical 3, and my units are meters. Sorry, that's where that comes from. The apothem we just found is 6, and my units are meters on that. Perimeter is made up of the side length. Perimeter is always of the biggest shape, which is, or the outer shape, which means I have 3 sides, that the side length is 12 radical 3. So I want 3 times 12 radical 3. Remember, the whole numbers on the outside get multiplied together, so 3 times 12 is 36 radical 3. Perimeter's units are meters. To find the area, which is the whole goal, is to make sure I use the right parts of this. Area of a regular polygon, according to your formula chart, is A equals apothem times perimeter divided by 2. So apothem times perimeter divided by 2. My apothem is 6. My perimeter is 36 radical 3 divided by 2. Remember, when you want simplest radical form and your special rights, you want to just look at the numbers part that you're calculating. So on my calculator, I'm going to type in, let's see, 6 times 36 divided by 2, which leaves me 108, and then I have to remember to keep that radical 3 on the end. My units are going to be squared since this is area. All right, number 17 is a regular octagon, which means I have 8 sides, so my n in this problem is 8. We're going to find the measures of the perimeter and the area to the nearest tenth. So looking at this problem, I'm like, oh, it's a regular polygon. I could use the area of regular polygon formula, and I kind of need to follow the format of finding all the missing pieces. The apothem is already given to us. That's our 9.2. What I don't have is the side length or the half side that's going to help me find the perimeter for my formula. So I'm going to put an X on that right triangle. I can go ahead and decide I'm going to use Pythagorean theorem for this method, which means I don't need to find the central angle. The reason I'm using Pythagorean theorem is because I have 2 out of 3 sides in a right triangle. When you do Pythagorean theorem, your c is always the most important. So in our formula, a squared plus b squared equals c squared, your c is 10. So we want 9.2 squared plus x squared equals 10 squared. 9.2 squared is 84.64 plus x squared, and then 10 squared is 100. So I'm going to subtract 0.64 from each side. That gives me x squared equals 15.36. Now, because my answer is wanting nearest tenth of the final answer, it's okay to have decimals in this part. And to get rid of that squared, I'm going to go ahead and square root that number. So that comes out to 3.919-ish. Now, if that's 3.919, I need to double that to get my side length. So the side length is 2 times the amount we just got, 3.919. Now I'm rounding on my paper, but I'm not going to round on the calculator. I'm going to still just leave that number up and just multiply directly by 2, so I'm not double rounding, and that gives me a side length of 7.838. Now again, my goal is to find the perimeter. If I have 8 sides, then I want to take the number of sides and multiply it by the side length, which would be 7.838. So I'm going to take that last number on my calculator and multiply by 8. So that gives me a perimeter of 62.70, we'll say 7 rounded. And that would be units meter. Now our goal is to find area. So we're going to use the area of regular polygons formula, which is apothem times perimeter divided by 2. Apothem they gave us in the formula in the picture was 9.2. My perimeter we just calculated is 62.707. And we're going to divide by 2. So again, I'm using the most recent number on my calculator, multiplying by 9.2 and dividing by 2. So that comes out to 288.45. Since they want nearest tenth, the 5 behind the 4 is going to round the 4 up to just 0.5. And this would be meters squared for area. Now when you double round, that's when your answers are going to be off a little bit. So make sure you don't round until the very, very end of the problem. And that will change when we do trig. All right, looking at number 19. 19, the apothem is 3. The apothem goes right there. I don't have my radius, and I don't have my half side. We'll call that x. Okay, before you can go any further, you have to calculate that central angle. Central angle is 360 divided by twice the number of sides we have. We have a 5-sided figure here. So 360 divided by 10 gives me a 36-degree interior central angle. Now if that's 36 degrees, I cannot use special rights. I don't have 2 sides to do Pythagorean theorem, so I have to use SOHCAHTOA, which is trig. When you label your triangle first, label in terms of O, A, and H. So opposite would be across. Actually, let me use a different colored pen. So this is opposite. Adjacent is next door. Hypotenuse is the longest side. So that way it tells you which piece of SOHCAHTOA to use. Now you can only relate your answers or your number that they're giving you to one of your variables. So let's say we find the radius first. If I'm finding radius, I have to compare 3 and R, which are my A and H. A and H are together in the part, so I would say that cosine of my angle, 36, equals, and remember it's always in order of what you see, it'd be A over H. A is 3, H is R. With R being in the denominator, This tells me to flip-flop my spots because I'm actually going to divide the number in my trig function, which would be r equals 3 divided by cosine 36. This is what you type directly into the calculator. So I'm going to, on my calculator, zoom out a little bit. So clear it. You want to double check that your mode is highlighted on degree. If it's not, click enter on degree. And I'm going to do 3 divided by cosine 36, which comes out to 3.71. Okay, so 3.71 centimeters is my radius. Now we need to do another trig function to find the side length or the half side length. This time we're finding x, which is an opposite side, and comparing it to the adjacent. O and A tells me to use TOA to find x. So I'm going to say that tangent of my angle 36 equals O over A, which would be x over 3. Now that x is on top, this tells me to multiply my number in tangent. So that would be 3 tangent 36. I'm going to type that in the calculator. 3 tan 36 comes out to 2.18. So I'm going to say that the apothem is, hello, dyslexic moment. Where did my whiteout go? My apothem comes out to be 2.18, not 2.81. Sorry, y'all. 2.18, and then it's centimeters. Before we go any further, that is my half side length. Okay, if my half side length is 2.18, I need to double it to get the full S. So 2.18 times 2 is where I get this number, and that's going to be 4.36 centimeters. To find the perimeter, I need to take my side length and multiply by the number of sides we have, which would be 4.36 times 5, which comes out to 21.8 centimeters. I think the rounding is different on the key than what I'm doing, but I just want y'all to see like the most exact, and then your directions may change based on your test. So make sure you read the directions in the test. If it says round your answer to the nearest tenth, round them to whatever, it's different in every problem maybe, so just make sure you're paying attention to that. Because this would round up to the 22 that's on the key. All right, to find area, that is our A times P divided by 2. Your apothem is given to you, so that's 3. Your perimeter is 21.8, and you want to divide by 2. So I'm going to multiply by 3 and divide by 2 on my calculator, which comes out to 32.69 centimeters squared. This rounds up to 33 if you were getting a whole number answer, which is on the key. All right, number 21 has 1, 2, 3, 4, 5, 6, 7, 8 sides. So my n is 8. We'll go ahead and calculate the the central angle. So 360 divided by twice the number of sides comes out to, comes out to 360 divided by 16. Comes out to 22.5. So that angle in the center is 22.5. Things they gave us, the apothem is 6. I don't know the radius. I don't know the side, so I'm going to put variables there. Your angle is 22.5, which tells me I can't use special rights. I cannot use Pythagorean theorem, so I'm going to have to use trig. There's not really a lot of space below this, so sorry, y'all, we might have to write in a different spot. But again, we want to label our sides. We have O is on the x side, the adjacent is 6, and the hypotenuse is r. If we're finding the radius first, I wanted to use A and H, which we go back to SOHCAHTOA up here. Tells us to use AH would be CUP. So I'm going to say cosine of my angle, cosine of 22.5 equals A over H, which would be 6 over R. Since we're dividing by R, I'm going to type in my calculator 6 divided by cosine 22.5. That comes out to 6.49. So my radius is 6.49 meters. I'm going to do the same thing, but now I'm going to do it for x. X is the opposite side, and I have adjacent, so O and A would be TOA. So that's tangent of my angle equals O over A, which is x over 6. You cannot see that, sorry. Okay, x is on top, which tells me to multiply my numbers together. So 6 tan 22.5. 6 tan 22.5 comes out to about 2.49. Now, again, you want the whole side, so I need to take this number, which is just the triangle, and multiply by 2 to get the side length, which comes out to 4.97 meters. And to get the perimeter, I'm going to take this side length and multiply by my number of sides, which is 8. So 4.97 times 8 comes out to 39.76 meters. And again, you guys, remember I'm using the unrounded version here to just plug in to find the next side lengths and stuff. All right, we go back to finding area, which is little a times perimeter divided by 2. In our case, little a is 6. It was given. Perimeter is that 39.76 divided by 2. So I'm going to take my most recent number, multiply by 6, and divide by 2. Comes out to 119.29. And that would be kilometers. Oh, are these kilometers the whole time? Sorry, y'all. Kilometers squared, so that would be kilometers, kilometers, and kilometers. Whoops. Make sure you have the right units. Don't make my mistake. All right, I'm not going to work all of 23. I'm just going to get y'all started because it gives you a little different piece. Perimeter is given to you this time. What the perimeter is made up of is each side length. So if perimeter is 42, I need to divide that by the number of sides that we have in this problem, which is 1, 2, 3, 4, 5, 6, 7. So I want 42 divided by 7, which gives me each side length of 6. Now, if the whole side is 6, that gives me the first blank being 6 meters. But unfortunately, that doesn't give me enough information. So when I draw my apothem and my radius, if I have the whole side length is 6, I need to go backwards into the right triangle. So half of that would give me that side length of 3. And then again, we need to find that central angle. If our n is 7, I'm going to do 360 divided by twice the number of sides, which is 360 divided by 14. Oops, hello. That comes out to about 25.7 degrees. So this angle right here is 25.7 degrees. So now I'm going to have to go backwards and find the apothem and the radius using trig. So I have an opposite side is 3, my adjacent side is A, and my hypotenuse is R. So we'll do that same thing to get your A and your R for the rest of the problem. All right, let's go down to the next questions. The next questions are probability questions. You need to be very careful when you're calculating these and actually make sure you're looking at your formula chart, because if you're doing all the right work, it would stink to be plugging into the wrong formula the whole time, and so you're gonna get the wrong answer. All right, so here we have number 29. I guess I should actually show you it. There we go. Too zoomed in, sorry y'all. All right, so we want probability, which would be the area of what we want over the area of the total. Now, if we want shaded region, that means we need the space between the square and the circle. Well, if I want between the square and the circle, I need to take the area of the square and subtract out the area of the circle. That's what, like I'm taking this and just scooping out the circle to leave these corner pieces. So my area of what I want is the area of the square minus the area of the circle. The area of the total shape, well, the whole shape is a square. So I just need to put that over the area of the square. All right, let's actually calculate these pieces. Area of square, when I look at my formula chart, area of a square is the side squared. The side length here is 12, so 12 squared comes out to 144. Then I need to find the area of the circle. If the circle fills the square, that means from end to end, this length would be the same length of the square, which is 12. Well, if I just want a radius to find area of a circle, because area is pi r squared, the radius of that is no longer 12, it's going to be 6. So I'm going to plug pi 6 squared into my formula for area, which comes out to 36 pi. We'll just leave it as that so we can plug it in and kind of not get messy numbers. So now if I want my probability, I'm going to take the area of the square, subtract out the 36 pi, which is my circle, and divide it by 144, which is the area of the square. Remember with these, we want our answers in fractions or in percents. Because we're going to get janky fractions, you want to make sure you do percents on these geometric area ones. So I'm going to type in, making a big mess over here. All right, 144 minus 36 pi. And then I'm going to take that number and divide by 144. Either do it in 2 steps on the calculator or make sure you put parentheses around the top before you divide in 1 step. All right, you guys, that comes out to 0.2146. If I'm going to take that and turn it into a percent, I need to multiply by 100, which rounded to the nearest tenth would be 21.5. Oh, you can't see that. 21.5. So it would be 21.5%. That's my final answer. All right, number 31. 31, we want the area of the shaded region again. So area of what I want over area of the total would come out to, the area I want is the big shape, which is a trapezoid. So I want to take the area of a trapezoid and scoop out the area of this rectangle. And I'm going to divide it by the area of the total shape, which would be area of trapezoid. So the 2 formulas we need, area of a trapezoid, regular formula is height times base 1 plus base 2 divided by 2. And then the area of our rectangle is just length times width. So let's find the individual areas before we plug into our answer. The height of my trapezoid is the space between the bases, which would be 8. The length of base 1 is 10. I'm going to add that to the whole length of base 2, which would be 16, and divide that number by 2. So in my calculator, you guys remember this is a plus sign. 10 plus 16 is 26. So I really want 8 times 26 divided by 2. That comes out to 104. So now if I'm going to do length times width for the square, the length of the rectangle, the length is 10, the width is 8, which is 10 times 8, which comes out to 80. So now back up to our probability. I want to take the area of the trapezoid, which is 104, subtract out the 80 from the square or rectangle, and then divide that by the total area of the trapezoid. So big minus little over big. This reduces to 104 minus 80 divided by 104 comes out to this decimal, 0.23076. So if we're going to multiply by 100 to turn that into a percent, comes out to about 23.1%, which would be our final answer for that one. All right, guys, last page. Number 33 is at the top. There it is. All right, probability is always what we want over the total. Make sure you're reading the question right. Is this the number I'm given what I'm using, or do I want the opposite, the leftovers of that number? Number 33, what is the probability of rolling a 2 on a dice? It is not the number 2 that I want. It is how many of those 2s. can I possibly get on a dice? On a dice, you have 6 total faces, so the total is 6. However, the number of 2s that I have on one dice is just 1. So the probability of getting a 2 is 1 out of the 6 faces, which when I when I divide that out, I get the percent 16.6 repeating percent. Number 35 says Jill has 8 cats and 5 of them are girl cats. What is the probability that when she picks one of them up, it's a girl cat? So what I want is girl cat over the total. So I have 5 girl cats. That would be 5 over the total 8 cats, which would be 5 over 8. Divide that and turn it into a percent by multiplying by 100 would give us 62.5%. Number 37, if Shelly shoots a basketball 18 times and she makes 7 of them, so I'm underlining 18 times, I'm underlining make 7, what is the probability that she will make the next basket? So we want probability of making over the total. So what I want is making a basket. Well, she makes 7 of them out of 18 times she's shooting, so the total would be 18. So then 7 out of 18 turned into a percent would be, 38.8 repeating percent. Number 39. A classroom has 11 girls out of a total of 23 students. So this is 11 girls and total of 23. What is the probability that if chosen at random, a student would be a boy? They didn't give me information about a boy. They only gave me the girls. Well, if I wanted the opposite, if I have 23 students and 11 of those are girls, I want to find out, well, how many are left to be a boy? So 23 minus 11 comes out to 12, which means I have 12 boys in that classroom. So my wants of picking a boy would be boys over the total, which comes out to 12 over 23. So when I divide that out, multiply by 100, that gives me 52.2% for my final answer. This is one of those where I gave you a number, but I want the opposite of that number, so you need to subtract from the total first and then divide by the total. It's kind of like our geometric probability where you do big minus little over big, or the total minus, yeah, that's pretty much it. Sorry, I got distracted. All right, you guys, that is all for this review. Make sure you study and ask questions during class or come into tutoring.